Hi all, welcome to session 15 of Azure Data Factory. And so far we have covered the copy data activity in Azure Data Factory. In the last 14 sessions, we covered different nuances of copy activity, how to use it, what are the different tabs, what is the significance of each option in the copy activity, and how to utilize it. But in this session, we are not going to do any hands-on. I'm just going to tell you the bigger picture of Azure Data Factory. So if I go down to the next slide, when we are working in data engineering, we are basically building data pipelines. So data pipelines are workflows that perform certain steps on data while moving data from source to sink. Okay, so based on the order in which these operations are carried out, the data pipelines can be built by three different ways. First is ETL, known as extract, transform, and load. Second is ELT, known as extract, load, transform. Third is just an enhancement of second, that is ELTL, extract, load, transform, load. Okay. Traditionally, we used ETL approach. That means while we are moving data from source to sink, we used to transform the data on the go. So suppose if you are running a select statement on a database and you want to get the data into a data warehouse, your select statement will have the logic that you want to perform on the data before pushing the data into your data warehouse table. Okay, so that way your transform operation was happening before the loading of data. But this particular approach is not a very good approach when it comes to dealing with the big data scenarios. Because what will happen is that the transformation will take a lot of time. So, suppose if you are working on a data set in which you want to perform sorting, because you want to get top 10, top 20, something like that. And if the data or the table on which you are performing sorting is very huge, suppose it has a billion records, the transform will take a lot of time and it is going to slow down your entire data pipeline. So ETL in the big data world is not an ideal option. Okay. So keep this in mind and we will discuss about second and third option later. Okay. So let's start with the ETL because it was the first model on which the data pipelines were built, and it was the model on which the ETL tools used to work like Pentaho, Informatica, and etc. Okay. Now they are also working on the ELT approach. Informatica has given that kind of feature. I don't know about Pentaho, but traditional ETL tools used to work on the ETL approach, that is extract, transform, and load. Okay. Now in the ETL approach, what you are doing, you are extracting the data from the source, you are transforming it in between, and then you are loading the data in sync. Okay. Now while you are doing extract, you are also performing transformation. So what is the main problem with this approach is that when you are working on the extraction, suppose if you want to perform transformation on the data itself, it is going to be consuming the resources of the source. So suppose if you have a server on which the database is running and if you want to perform a transform operation, there has to be a compute power somewhere. So either your database server has to take care of the transform, or you will have some intermediate compute where your data is going to be transformed before you load the data into sync. Okay. So transform can become a bottleneck. How? When you are doing the transform, suppose your machine breaks down, or suppose your database gets into a position where you cannot pull the data. Suppose the table rows are locked. So in those scenarios, your transform either your transform will either time out or it will have to wait till the data issue is resolved. Something like that. So in that scenario, your extract, transform, and load process will take a lot of time to move the data from source to sink, and it will be a slow process. Okay, so that is why in the case of big data scenario, this approach hardly works. You will not see much use of ETL approach in your big data systems when you are working with real time data where lots of data has to be processed. ETL approach is not the right way. So what we did, instead of coming with ETL, we came with ELT approach. So in ELT, what we are doing, in ELT, we are basically using ADF to extract the data and then load the data as it is in its raw format in the data lake. Okay, so mind you, we are not doing any kind of transformation, it's simple copy activity. So the ADF that you are seeing here and the place of transform is actually just copying the data that you want to transform later into a store called as data lake. Data lake is kind of a raw storage area where you dump all the data. Okay, no matter whether data is structured, unstructured, semi structured, if you have some use of the data, you will put that data simply in its raw format in the data lake. Okay, transform will take place later, so you will not worry about transform at this particular step. So your EL approach, that is your extract and load approach, is going to be happening on the ADF, and that is using copy activity. So in the ELT, what is the basic advantage over ETL is your data is now sitting on the data lake. Now data lake is very cheap, okay, and it can store a lot of data, and also the data of different types can be stored here. So because of this, you have the flexibility to apply distributed computing frameworks like Spark and Hadoop on top of it. So the transform process can take a much faster approach with the distributed processing frameworks on the data lake. So that way, even if your data is huge, if you are storing the data in the data lake, you will be able to perform the transform operation quite quickly, and you have the control on your data. So for example, in the database you have the application, and in the source you have a database, application database, and that application database is also serving customers. Okay, and if you perform transform operation on the database while loading the data from database into sync, your resource on the database is going to be consumed, and that may impact the customers who are working on that application, because database also has to serve the customers. So in that particular scenario, your database will be slow, or there will not be like a responsiveness that users are expecting. So ELT approach is very good when you are working in the data engineering landscape with the big data. So you can extract all the data that you want on schedule basis from using ADF copy activity from different sources, put into a location that is cheap and can be scaled based on the data size, and then whatever transform operation you want to perform on that particular data that you have stored in the data lake, you can take it independently. You don't have to rely on the source, and that way your source is also free, and your data that you have stored in the data lake can be consumed at your own will. The enhancement on top of this is ELTL. Okay, so the next step that you can add is transform activity on top of ELT approach. So in the transform activity of ADF, you can use different options of Azure. So you can use Databricks, you can use a stored procedure. There are multiple ways to perform data transformation in ADF. So whatever data you have stored in your data lake, that is your ADLS Gen 2 account, on top of it you can perform transformation using different Azure services, and then your final data can be loaded into sync. Again, this particular thing from ADF to sync, the data load can happen using ADF copy. Okay, so the bigger picture that I was talking about is ADF copy is the EL part of your pipeline. So you are extracting the data from source and you are putting the data into data lake using ADF copy activity. So that is why if you are working in Azure and you are using Azure Data Factory, the knowledge of copy activity is a must. So basic understanding of copy activity, how to configure it, how to use it to configure source and sinks, how to use it to perform copy into your data lake in an optimum way. All these things matter a lot, and that is why I put so much emphasis on ADF copy activity. Now if you have a basic idea of a copy activity, what are the different options that you have, then it is easy for you to put the transform on top of the data that you have copied in your data lake and get the desired output to your customers for the use. So you can have your transform activity running a Databricks notebook that will perform operations on top of your data that is sitting on data lake, and it will give the data back into a, let's say, Synapse or SQL database, or it can train a machine learning model. Whatever you want to do with your data basically can be done using the transform activity. Okay, so this was the bigger picture. So that is why we put so much emphasis on data as copy data activity, and now from here we will build on top of whatever we have learned. So from the next session onwards, I'm going to do hands-on, where we are going to pull the data from sources using copy activity, and then explore the other activities that are there in the data factory. Okay, so thank you for joining me, and we will meet in the next session. Thank you so much.